In this lesson, we move on to solving absolute value inequality problems. Let's start out with a couple of very simple ones. We want to write or name all the values whose absolute value is less than or equal to 6. Well, I can tell you 5, 4, 3, 2, 1, 0 work, but I also have to include the negative values. So really, these are the numbers from -6 to +6. And it can include either one. So I look at that and I say, well, this also looks like an AND type problem because it's in between two values. Now over here, we want to name all the values whose absolute value is greater than or equal to 3. Well, 3, 4, 5, 6, 7 forever definitely works. So those are all those numbers represented here. But what about -4? Its absolute value is greater than 3. So if I move from -3 on down to -infinity and take all those numbers' absolute values, I'm also creating a true statement. This, on the other hand, looks like an OR problem. Now, there's a couple ways that I remember this. Actually, one. I take a look at the absolute value sign and the unknown, and I say the absolute value of the unknown is less than, and it's a little bit of a stretch, but less than kind of sounds like and then the absolute value of something is greater not how you spell it, but you get the idea, greater than the other. So absolute value of something is greater is like an OR problem. Absolute value of something is less than an AND problem. Now, mathematically, when we talk about solving these problems, we could state that to remove from the absolute value, you have to go plus or minus some x is less than or equal to 6. So I have two equations. X is less than or equal to 6, and we just got done saying less than, and -x is less than or equal to 6. So solving this, I divide by -1, and I have x greater than or equal to -6. And if I were to graph that, its graph is right here. Likewise, in this problem, plus or minus x is greater than or equal to 3. So I have x is greater than or equal to 3. Or, because of greater, -x is greater than or equal to 3. Divide by -1. And I have x is less than or equal to -3. Graphing that, there it is. So, same situation as we had earlier in our absolute value equalities with our absolute value inequalities. We want to get rid of the absolute value because we can't work within it and create two equations, a plus or minus equation to remove that absolute value sign. So, again, here's an absolute value less than or equal to, so we know this guy is going to talk about an AND problem. And I have plus or minus x plus 3 less than or equal to 5. Write my two equations, x plus 3 less than or equal to 5, and the opposite of x plus 3 is less than or equal to 5. Solving, I subtract 3 to both sides, and I get x less than or equal to 2, and Now in these problems, I typically divide by -1 on my first step. And when I do that, I flip the inequality sign. And then I'll subtract 3 to both sides. And I get x greater than or equal to -8. So graphing this, here's my 2 and equals. And then here's my -8 and equals. And it's an and. So while this goes this way and this goes this way, I take the overlap. So it's between those two. Interval notation, I go -8, 2, bracket both, since they're included. Next, very similar problem, except in this case, greater than problem. So this is an or. And I have plus or minus 5x minus 7 greater than 13. So I have 5x minus 7 greater than 13. The opposite, 5x minus 7 greater than 13. It's an or. So I add 7 to both sides. 5x greater than 20. Dividing x greater than 4. Again, I have an or. We'll divide by -1 for a step. Less than -13. And 5x minus 7. Add 7. Get -6. And 5x. Divide by 5. X less than -6/5. I take a look at that graph. Here's my -6/5. Open circle. Less. +4. Open circle. Greater. It's an or problem. Stating in interval notation, I go from -infinity to -6/5. Not included on the 6/5, parentheses. -infinity can't be included because it's undefined. In union with because it's an or, going from 4 to infinity, both not included, so parentheses. This problem is a little more complex because I've got this 1 added to the absolute value. Remember, we have to isolate the absolute values first. And notice we're going to have to deal with this fraction afterwards. So I'm going to subtract 1 from both sides so I can get an isolation. I have 5 and then 2x plus 3 over 7. So now if we look at this problem, it says 5 is greater than or equal to. Now the mistake on this is to say this is greater, so it's an or problem. The mistake is that you're starting with the 5. You need to start with the unknown quantity first. So the unknown quantity is less than or equal to. So this talks about an and. So what we have is we have 5 greater than or equal to plus or minus 2x plus 3 over 7. And remember, it's going to be an and problem. So let's go ahead and begin to solve. I have 5 greater than or equal to 2x plus 3 over 7 and 5 greater than or equal to the opposite of 2x plus 3 over 7. So in this case, I'm going to get rid of that fraction and I'll multiply both sides by 7, giving me a 35 greater than or equal to 2x plus 3, because the 7's just reduced. Remember, that's like a 7 over 1. Add through, or subtract 3 to both sides, rather. 32, divide by 2, get 16 less than or equal to, or greater than or equal to x, then in this case, I'm going to multiply both sides by a negative 7. Negative times a negative will go to a positive, and these 7's reduce. So this gives me a negative 35. Because I'm multiplying by a negative, I flip the inequality, and I have 2x plus 3 again. Subtract 3, negative 38, 2x, divide by 2, negative 19. If I want to graph this, I have my negative 19 included, closed circle, going to the right, and I have a 16 included going to the left. Where do they overlap? In between the two. Since they're both included, if I was doing interval notation, start at my small number, which is a negative 19, go to my big number, which is a 16, both included, therefore brackets on both. Another similar problem, except I've got two things going on now. I have an addition of 5 and a multiplication of 3. I need to isolate the absolute value before I get going. I subtract 5 to both sides, which gives me a 21. I divide by 3 to both sides. Giving me a 7. And the absolute value of 2x minus 1. Now again, start reading from the absolute value or the unknown. The unknown is greater, so this is an or problem. And now I need to go my plus or minus. So I have 7 less than or equal to plus or minus 2x minus 1. Set up my two equations from here. 7 less than or equal to 2x minus 1, or 7 less than or equal to the opposite of 2x minus 1. Add 1 to both sides. Get 8. Or distribute, or in this case I'm going to divide by a negative 1, giving me a negative 7. Flip the inequality and get 2x minus 1. Again, add 1 to both sides. Divide by the 2. And then get negative 3 greater than or equal to x. So now if I take and solve these, or actually graph them, oops, I have a negative 3 and all values less than that. Negative 3 is included and all values less. And then I have a 4 and all values greater, like so. So this is our OR problem. Looks like an OR. If I want to go interval notation, small number, negative infinity. Big number, negative 3. 3 is included. Infinity is not. It's an OR, so I union. Then I go 4 to infinity. Infinity is not included. 4 is. This problem, we want to solve this absolute value and put it on a number line. When is, I see this negative 10 and I start questioning things. When is an absolute value less than a negative number? Well, we talked about absolute values being distance away from 0. And distance is defined as a positive term. So, when is a positive less than a negative? Never going to happen. So there's no solution here. and problem over. In this case, this is just the opposite. When is the absolute value of something greater than a negative? Well, remember, this is always in terms of a positive number or a positive value distance. And when is a positive greater than a negative? Always. So this is all reals, which means we go from negative infinity to positive infinity, neither of which can be defined, so they go both in parentheses. Now, if we take a look at a number line and we want to write an absolute value for this, we need our central value and then our variation number on either side. So these are my two answers, but I know that these two answers are equidistant from a middle number. So if I look at what number is between 1 and negative 7, well, here I have a total of 8 spaces, which means 4 is dead center middle. So 1, 2, 3, 4, which puts me at negative 3. And then 4 more, 1, 2, 3, 4, is my equidistant space. So now what I've got is I've got this central number, and I'm varying positive 4 from one side and negative 4 from the other of negative 3. So I'm taking negative 3 and going as high as 4 to one side, as low as 4 to another side, and that's equal to some x value. Again, we want to get this plus and minus by itself because we know plus and minus comes from an absolute value. I add 3 to both sides. I get x plus 3. And now we're going to have to deal, because this is not an equality. I'm looking like an OR problem right here. So my absolute value is going to have to be greater. So I'm going to take and say, well, this is greater than plus or minus 4. Get rid of the plus or minus by adding an absolute value. And here's my absolute value inequality statement. Again, the original graph looks like an OR problem, so whatever is the unknown needs to be greater than the number. Similar problem, but this clearly is an AND, because it looks like an in-between type problem or an intersection or overlap. Again, I should have some middle number. I'm going from 1 to 11. There's a total of 10 spaces between, which means I have 5 on either side. 5 away from 1 gets me to 6, and 5 away from 11 gets me to 6 as well. I'm as high as 5 to the right and 5 to the left of 6. 6 is my central number. My variation is 5 to either side. It's an AND problem, so I have x is less than or equal to. I'm going to bring the 6 over. And then I want to get rid of the plus or minus, so I add an absolute value. And I've got the absolute value of x minus 6 is less than or equal to 5. So, little word problem. We've got a restaurant saying you've got an entree that has 480 calories, and based on the size of the chicken, you can vary, which means you can go up or down as much as 40 on either side. Like so. Now, that means I've got values going as high as 520 or as low as 440. and I could have anything in between, like so. Therefore, in this case, what I want to do is I want to state this as an absolute value that looks like an and. So I'm going to take and say, well, if this is and, I have x is less than the 480 and a range of 40 above and below. Bring the 480 over. Get rid of the absolute or get rid of the plus and minus by putting in an absolute value. And there is my statement. So here's my inequality, and here is my range between 440, and 520. That's it. Make sure you do the assigned problems and fill out your lesson summary. We'll chat more tomorrow.